The James Webb Space Telescope, our greatest window into the distant universe, has stunned astronomers once again. With its cutting-edge infrared capabilities, this marvel of engineering has made a chilling discovery, one that reshapes how we view planets that were once thought to resemble Earth. Not long ago, the infrared Spitzer Space Telescope led us to a groundbreaking revelation: a solar system with 7 rocky exoplanets orbiting a single star, TRAPPIST-1. These planets excited scientists across the globe due to their Earth-like size and their potential to harbor life. But as with many things in space, reality is far more complex than hopeful assumptions. Now, the baton has been passed to the James Webb Space Telescope, our most powerful eye in space. When Webb turned its sensors toward the TRAPPIST-1 system, anticipation soared. One planet in particular, TRAPPIST-1b, drew immediate interest. It had all the preliminary signs of being an Earth analog. But then came the data. Using its advanced mid-infrared instrument, MIRI, Webb measured the planet's thermal emissions. What it found was not promising. It was shocking. TRAPPIST-1b's surface was blistering hot. The average temperature reached a staggering 450 degrees Fahrenheit, hotter than most ovens on Earth. That heat alone was a deal-breaker, but it wasn't the only problem. The planet also appeared to lack a meaningful atmosphere, stripping away any hope for surface habitability. Despite the disappointing outcome, this was a monumental moment for science. For the first time ever, humanity had directly measured light emitted by a rocky planet outside our solar system. Think about that for a second. Not a gas giant like Jupiter or Saturn, but a small, rocky exoplanet. That level of sensitivity and reach proves that the James Webb Telescope is not just a step beyond previous telescopes. It's a leap. And yet, this was just the beginning. Astronomers aren't just interested in what's hot or cold, they're after life, or at least the conditions that could support it. With TRAPPIST-1b turning out to be inhospitable, attention began to shift to its neighboring planets. Maybe, just maybe, one of them might be in the Goldilocks zone. Not too hot, not too cold, and with the right atmospheric ingredients. The Webb telescope will continue its mission, peering deeper, capturing thermal fingerprints of exoplanets, decoding their atmospheric makeup, and giving us unprecedented insights into alien worlds. Every scan it takes is like flipping a page in the cosmic story of who we are and where we might find company in the galaxy. But this segment's focus isn't just on TRAPPIST-1b. It's about the bigger message, that even Earth-like planets might be wildly uninhabitable, and that life, as we know it, could be far more rare than we hope, or perhaps simply far more different than we imagine. Stay tuned, because this is only the first chapter in the James Webb Revelations. In the ever-expanding universe of discoveries, some of the most important findings are the ones we nearly overlook. Segment 2 of our cosmic journey picks up from where we left off. And this time, the focus is on a planet that almost slipped through our fingers. Kepler 1649c. As the James Webb Space Telescope and its predecessor instruments scan the heavens, certain exoplanets stand out not just because they exist, but because of how much they resemble Earth. Among those is Kepler 1649c, a planet astronomers now call the Earth twin we almost lost. Let's rewind to 2022. Using data from NASA's retired but legendary Kepler Space Telescope, scientists noticed something peculiar. A planet that had previously been discarded as noise in the data was suddenly recognized as something very real and very promising. This rediscovery wasn't a lucky guess. It came from a special machine learning program called RoboVet, designed to scan through troves of discarded Kepler data. When RoboVet flagged Kepler 1649c, scientists took a closer look, and what they found was astonishing. Kepler 1649c orbits a small, cool red dwarf star called Kepler 1649. It's roughly 300 light-years away, relatively close in galactic terms. More importantly, this planet is nearly identical in size to Earth and sits within the habitable zone of its star, the so-called Goldilocks zone, where conditions might just be right for liquid water. But wait, there's more. Not only is Kepler 1649c the same size as Earth, but it also receives about 75% of the light our planet gets from the Sun. That suggests temperatures on the surface could be similar to what we experience here on Earth, assuming it has an atmosphere to regulate those temperatures. And here's the thrilling part. Scientists believe that if this planet does have an atmosphere, it could sustain conditions suitable for life. Imagine that, an Earth-like planet, hidden in plain sight, only discovered because of a sophisticated AI digging through old data. The rediscovery of Kepler 1649c is a powerful reminder of how much we still have to learn, and how many cosmic gems might be hiding in the data we've already collected. It's a call to revisit our assumptions, to trust in evolving technologies like machine learning, and to remember that the search for life doesn't end with brand new observations. Sometimes it begins with old files and new eyes. But let's talk about the possibilities. If Kepler 1649c does turn out to be habitable, it could become one of the top candidates for future space missions, both robotic and maybe, one day, human. While 300 light-years is far beyond our current reach, this planet gives us something invaluable: hope. Hope that Earth isn't unique. Hope that life might thrive elsewhere in the galaxy. Hope that we're not alone. In contrast to TRAPPIST-1b, which burned away our dreams with its scorching surface, Kepler 1649c invites curiosity and wonder. It suggests that the universe still holds secrets we're not ready for, and that somewhere out there, a planet much like ours might be quietly waiting to be found again. The hunt continues. The excitement grows, and the telescope lenses of the future, including James Webb, Roman, and beyond, are aimed at deepening our understanding of these distant worlds. So what do you think? Could Kepler 1649c be Earth's true twin? Stay with infinity beyond as we travel further into space, uncovering more secrets, one planet at a time. Space is not just empty silence. It's an invisible battlefield. And Earth, our home, is constantly under attack from radiation, solar flares, and high-energy particles. Yet somehow we survive. Why? Because Earth has an unsung hero, its magnetic field, an invisible shield that protects everything we know and love. Welcome back to Infinity Beyond, where today we unveil the science behind Earth's most powerful force of protection. Let's begin with something mysterious: the Van Allen radiation belts. These two donut-shaped regions encircle the Earth with high-energy charged particles trapped by the planet's magnetic field. Without them, Earth would be constantly bombarded by deadly radiation from the Sun and beyond. But here's a little-known fact. Just below these belts lies a recently discovered bubble of ultra-low-frequency radio waves. This bubble wasn't created naturally. It's human-made. Over the last century, our civilization has filled the near-Earth environment with very low-frequency, VLF, transmissions, used in everything from radio communications to military systems. At first, no one noticed, but scientists began to realize that these man-made waves were interacting with space itself, pushing the outer boundary of the radiation belts farther from Earth. In other words, our own technology, unintentionally, may have created a kind of artificial protective layer. Imagine that. We not only live under Earth's natural magnetic umbrella, but we might also be reinforcing it with our own radio chatter. The universe, it turns out, listens, but the Earth's magnetic field does more than manage radiation belts. It's the reason we see auroras, those magnificent curtains of green, purple, and red that dance across polar skies. When solar wind, a stream of charged particles from the sun, strikes Earth's magnetic field, it's deflected and funneled toward the poles. There, it energizes atoms in the atmosphere, creating the light show we call the aurora borealis and aurora australis. Beautiful, yes, but also deadly. If not for that magnetic guidance system, this all works wonderfully on Earth. But step outside that shield, say, into orbit or deep space, and the story changes fast. Astronauts aboard the International Space Station, ISS, still benefit from Earth's magnetic field, but only partially. The further they go, the weaker the protection becomes. Once they travel beyond the magnetosphere, all bets are off. The exposure to cosmic rays and solar particle events can be life-threatening. That's why missions to the Moon or Mars are not just engineering challenges, they're radiation challenges. We can't send humans too far from Earth for too long unless we solve this cosmic vulnerability. But here's the inspiring twist. By studying how our VLF transmissions accidentally expanded Earth's protective bubble, scientists are exploring ways to create artificial magnetic shields in space, essentially mimicking Earth's magnetic field using magnetic coils, plasma clouds, or directed electromagnetic pulses. If we could generate a mobile magnetic field, we could surround spacecraft and even future Mars habitats with protective cocoons. It's early research, but promising. And it all begins with understanding the invisible forces that guard our world. So next time you hear a faint radio hum or see the aurora glowing in the night, remember, you're witnessing the very forces that shield humanity from annihilation, both natural and possibly human-made. And in the grand adventure of space exploration, our future may depend on learning how to take those shields with us. As we look to the stars for new worlds to call home, one particular class of stars is capturing the attention of astronomers and dreamers alike: orange dwarfs. These humble, unstable stars may not be as bright as our Sun, but what they lack in flash, they more than make up for in lifespan and promise. Welcome to another mind-expanding episode of Infinity Beyond. Today, we journey to a promising candidate in the vast galactic real estate market, KOI 571501, a potentially habitable planet orbiting an orange dwarf. But first, why orange dwarfs? Our Sun, classified as a yellow dwarf, has a lifespan of around 10 billion years. It's currently about 4.6 billion years old, which means it's a middle-aged star. Sounds like plenty of time, right? But compared to orange dwarfs, it's barely a teenager. Orange dwarfs, also called K-type stars, can live anywhere between 45 to 70 billion years. That's nearly 7 times longer than our Sun. Their slow and steady burn creates a stable environment for billions of years, a critical factor when it comes to the evolution of life. If Earth had formed around one of these long-living stars, who knows how advanced life could have become by now? And that's what makes KOI 571501 so fascinating. Discovered using NASA's Kepler Space Telescope, KOI 5715.01 is a planet that checks all the boxes. It's Earth-sized, orbits within the habitable zone of its orange dwarf star, and has the potential to maintain liquid water on its surface. In other words, it might be just the kind of place we've been looking for. Let's break down its cosmic resume. The star it orbits is about 5.5 billion years old. That may seem a bit young on the orange dwarf scale, but keep in mind, Earth is only 4.5 billion years old, and life here is flourishing. In fact, some scientists believe the sweet spot for life may be around 7 billion years after a star forms, as it allows for both planetary cooling and biological complexity to unfold. KOI 5715.01 is right on track to hit that timeline. One fascinating feature is that its year, the time it takes to orbit its star, is around 190 Earth days. That means its seasons and cycles would be vastly different from ours. School might feel longer or shorter depending on the planetary calendar. Imagine starting kindergarten and graduating college before you hit what we consider mid-year. But here's what really stirs the imagination. If this planet has a slightly thicker atmosphere than Earth and is positioned just a little closer to its star, the skies there might be lighter, more colorful, and possibly even more vibrant than what we see on Earth. Think of skies tinged in soft ambers or golden hues, sunsets that stretch across the horizon in otherworldly pastels. A painter's dream born in astrophysics. And let's not forget the time advantage. While Earth's timeline is limited, our sun will eventually swell into a red giant and scorch our planet in the far future. Planets around orange dwarfs have billions of years more time to evolve life, develop civilizations, or become sanctuaries for future space travelers. That's the real treasure of KOI 57158.01. It's not just about where it is, but when. It offers a glimpse into worlds that have more time. Time to develop, time to thrive, and perhaps time for us to reach them. We're just beginning to scratch the surface of what planets like KOI 5715.01 can teach us. With instruments like the James Webb Space Telescope and upcoming missions, we may soon learn whether its atmosphere supports life, how its climate functions, and what secrets it holds. In the grand story of the cosmos, we've barely turned the page. But KOI 5715.01 is a compelling reason to keep reading. So, what would life be like under an orange sun? Peaceful, perhaps, or maybe bursting with color, sound, and evolution unlike anything we've ever imagined. Stay curious, stay inspired, and keep watching the stars, because the next Earth might be orbiting an orange sun. What if humanity's biggest threat isn't aliens, asteroids, or AI, but mosquitoes? Welcome back to Infinity Beyond, where today we dive into a shocking and controversial topic: how modern science is rewriting the laws of nature and possibly putting the future at risk. Let's rewind to a seemingly small yet deadly problem: malaria-carrying mosquitoes. Every year, this tiny insect is responsible for over 500,000 deaths globally. But what if we could genetically eliminate them? Enter the bold new world of gene drive technology. Gene drive is a method of genetic engineering that forces a particular trait to be passed on to all offspring, overriding the usual 50-50 inheritance of genes. This isn't science fiction. This is happening now. The goal? Eliminate deadly mosquito populations by altering their genetics so they can only produce male offspring. Since only female mosquitoes bite and reproduce, the population could collapse in just a few generations. The result? A world without malaria, and perhaps without mosquitoes at all. Sounds like a miracle, right? But with every scientific miracle comes a dark side. Here's the ethical dilemma. Once released into the wild, gene drives can't be undone. They spread through a population rapidly, even aggressively. What begins in one corner of the Earth could reach ecosystems across the globe, changing not just one species, but potentially the entire balance of life. Mosquitoes, as much as we despise them, are part of a complex food chain. Birds, fish, and bats all rely on them as a food source. Remove them, and the ripple effects could be massive and irreversible. And it doesn't stop with mosquitoes. The technology could, in theory, be applied to any living organism. Rodents, weeds, invasive species, even humans, in the wrong hands. Editing DNA on this scale could create entirely new species or eliminate existing ones, all depending on who controls the gene. There's a chilling thought. We might be one step away from designing, or destroying, life at will. Proponents of gene drive argue that its benefits are undeniable. Eradicating malaria, stopping Lyme disease, controlling invasive species in delicate ecosystems like islands, the potential is vast. But critics warn that we're entering uncharted territory. Unlike other forms of genetic engineering, gene drives are self-propagating. They don't just change individuals, they change populations. Entire ecosystems could shift within decades. And here's where it gets even more uncomfortable. Gene drive isn't a distant dream. It has already been tested in lab environments and in limited outdoor trials. The results are effective, shockingly effective. Mosquito populations dropped by over 90% in some experiments. But imagine a future where one small release of a genetically modified organism changes an entire region, or even the planet. No borders, no way to reverse it. Just permanent change. What's more terrifying, that we can do this, or that we might already have? International watchdog groups and scientific communities are now debating how to regulate gene drive technology. Who decides when and where it's used? Should the public have a say? Should entire nations vote before a gene is released into their environment? These are the kinds of questions that don't have easy answers, because we're the first generation in history to face them. Gene drive represents both the hope of humanity and its hubris. On one hand, it could solve problems we've faced for centuries. On the other, it could unleash consequences we haven't begun to imagine. And in a universe where we're still searching for other life, we must also ask, if we can edit life on Earth so freely, what happens when we find life elsewhere? Will we change it too? Maybe, just maybe, the question isn't, can we do this? It's, should we? Stay tuned, because in the next episodes, we'll explore how this same technology could be used to resurrect extinct species, and whether Jurassic Park might not be fiction after all. Volcanoes have shaped Earth's history, its landscapes, and even its climate. But sometimes, they do more than sculpt mountains. They rewrite life itself. One of the most chilling examples of this power comes from massive volcanic eruptions that spew colossal amounts of ash and gas into the atmosphere. When this happens, the world doesn't just heat up from lava, it cools down. Yes, cools down. Imagine the aftermath. A giant gray cloud of volcanic ash spreads across the atmosphere, blocking out sunlight for months, even years. The planet's surface temperature drops by several degrees, triggering what scientists call a volcanic winter. Crops fail, ecosystems collapse, and life as we know it faces a fight for survival. This isn't just a wild theory. It has happened before. Roughly 74,000 years ago, the eruption of Mount Toba in Indonesia plunged the Earth into chaos. The supervolcano released enough ash and sulfur dioxide to block sunlight for over a year, leading to one of the most devastating mass extinctions in history. Some studies suggest that humanity's ancestors were reduced to just a few thousand individuals during this catastrophic period. But supervolcanoes aren't the only culprits. There's also a phenomenon known as flood basalts, where an enormous bubble of magma accumulates beneath vast regions of Earth's crust. Instead of erupting in one massive explosion, it seeps out through cracks in the ground for thousands of years. This slow-motion disaster continuously poisons the atmosphere with toxic gases and devastates every form of life in its path. The scariest part? We can't stop it. While we've made progress tracking asteroids that might threaten Earth, predicting volcanic eruptions remains one of science's greatest challenges. Even if we knew a supervolcano would erupt in the next 6 months, there would be nothing we could do to prevent it. All we could do is evacuate and prepare, which is like standing in the shadow of an atomic bomb with only an umbrella for protection. And supervolcanoes don't just cause local destruction. Their effects are global. The ash clouds they release can spread across continents, altering weather patterns, blocking sunlight, and causing temperature drops severe enough to spark global food shortages. Take Yellowstone, for example, a supervolcano located beneath the United States. While it hasn't erupted in over 600,000 years, its potential eruption could release 1,000 times more material than Mount St. Helens did in 1980. Scientists believe the ash fallout could bury entire cities, poison water supplies, and make large swaths of North America uninhabitable for decades. So, what are we doing to prepare? Surprisingly little. Humanity has poured billions into asteroid defense strategies, and for good reason. But when it comes to supervolcanoes, our early warning systems are still developing. We monitor seismic activity, gas emissions, and ground deformation, but predicting an eruption is far from certain. A sudden burst of pressure could trigger a chain reaction that we simply wouldn't see coming. Yet, in this story of doom, there's also hope. By studying past eruptions and ancient lava fields, scientists are piecing together the patterns of volcanic behavior. They're also experimenting with new ways to mitigate disaster. From drilling to release pressure in magma chambers, to creating global emergency plans for food and shelter in case of volcanic winter. Could these efforts save us? Possibly, but only if we act before the next big eruption, not after. Supervolcanoes remind us of one sobering truth. While we dream of colonizing Mars, we must not forget the wild, unpredictable power of the planet we already call home. So next time you see a peaceful mountain on the horizon, ask yourself, is it truly asleep or just waiting? Let's start with Uranus, the planet that simply refuses to stand upright. Most planets rotate with a slight tilt, like Earth, which is angled at about 23.5 degrees. Uranus, it's tilted a staggering 98 degrees. That means it literally rolls around the sun on its side, like a cosmic bowling ball, one that somehow still manages to orbit gracefully with the rest of the solar system. This bizarre orientation leads to some of the most extreme seasonal changes of any planet. For decades, one pole faces the sun continuously, bathing in non-stop daylight, while the other is plunged into a frozen, dark abyss. Then, half an orbit later, they swap places. Imagine living in 6 months of unrelenting sunshine, followed by 6 months of pitch-black night. No wonder Uranus has earned a reputation as the weird kid of the solar system. But that's exactly what makes it so fascinating. Contrary to popular belief, Uranus still rotates in the same direction as most other planets. It's just doing it while tipped over. Scientists believe a massive collision with an Earth-sized object in the early solar system may have knocked Uranus sideways, forever altering its spin and its destiny. Now let's talk about Neptune, often overshadowed by its bigger siblings like Jupiter and Saturn, but equally deserving of attention. Some people casually call Neptune a blue Jupiter. That's like saying a dolphin is just a wet cat. The comparison doesn't hold up. Neptune may be a gas giant, but it's in a category of its own, an ice giant. It contains a higher proportion of elements like water, ammonia, and methane ices, giving it a denser composition and that stunning sapphire hue. And while Uranus may be the sideways wonder, Neptune is the storm champion. It boasts the fastest winds in the solar system, reaching up to 1,300 miles per hour, 2,100 km. That's faster than the speed of sound on Earth. Imagine standing in the middle of a hurricane that wraps the planet in a day. That's Neptune's normal weather. Its largest storm system ever recorded was dubbed the Great Dark Spot, akin to Jupiter's Great Red Spot, but darker, faster, and more short-lived. Neptune's dynamic atmosphere, shaped by internal heat and frigid temperatures, creates turbulent and unpredictable climate patterns, like a cosmic version of wild mood swings. Despite their differences, Uranus and Neptune share some key similarities. They're both rich in methane, which absorbs red light and reflects blue, hence their deep azure appearances. They're both cold, very cold, and they both have systems of faint rings and moons, including some bizarre and irregular satellites. One of Uranus's moons, Miranda, features cliffs taller than Mount Everest, and jumbled terrains that look like nature's attempt at abstract art. Meanwhile, Neptune's largest moon, Triton, is a frozen enigma that orbits backwards, a clear sign that it was likely captured from the Kuiper Belt. But here's what's most tragic. We barely know them. Since their discovery, only one spacecraft has ever visited Uranus and Neptune, NASA's Voyager 2 in the 1980s. In just a few brief flybys, it gave us the only close-up images we have of these mysterious worlds. No probes, no orbiters, no rovers, just snapshots. In a time when we dream of colonizing Mars and setting foot on the Moon again, the outer giants remain largely unexplored. Yet scientists believe that these ice giants may hold critical clues to understanding how planetary systems form and evolve, both in our solar system and in others. In fact, recent exoplanet discoveries have shown that Neptune-sized worlds are the most common type of planet in our galaxy. By understanding Neptune and Uranus better, we might unlock the secrets of entire planetary systems light years away. So maybe Uranus isn't just the solar system's punchline, and Neptune isn't just a blue gas ball. Maybe they're reminders that diversity is the rule, not the exception, even in space. And maybe, just maybe, it's time we went back to these frozen giants and gave them the exploration they deserve. Let's start with Mars, the planet we've pinned our hopes on for decades. Its dusty red surface has inspired science fiction writers, engineers, and astronauts alike. Rovers roam its barren terrain, searching for signs of ancient life. And yet, with all our fascination, the facts remain sobering. Mars has an atmosphere, but it's 100 times thinner than Earth's, composed mostly of carbon dioxide. That means it can't hold on to heat, and surface temperatures can swing from a sunny afternoon to Antarctic levels in hours. On top of that, without a thick atmosphere, cosmic radiation bombards the surface constantly. But here's the real deal-breaker. Liquid water can't survive on Mars today. Even if you poured it out on the surface, it would either freeze instantly or evaporate into the thin air. Scientists believe Mars once had water, maybe even vast oceans. So what went wrong? One theory is the loss of Mars's magnetic field. Without it, solar winds stripped the planet of its atmosphere over time. Another explanation? Mars is just too small to hold on to internal heat, meaning its core cooled faster than Earth's. And with that, its ability to maintain a magnetic field disappeared. Whatever the reason, the result is clear. Mars today is a cold, dry, and inhospitable place. Not exactly the vacation destination we were hoping for. And yet, hope isn't lost, because Mars has something rare in the solar system: accessibility. It's close. We've studied it more than any other planet, and it still holds ancient secrets beneath its surface. Subsurface water, perhaps microbial fossils, maybe even dormant life forms. That's why our missions continue. That's why scientists don't give up. Now let's journey further out to the true giant of the solar system, Jupiter. Massive, majestic, mysterious, but also absolutely inhospitable. Jupiter is made almost entirely of hydrogen and helium, forming thick gaseous layers that stretch deep toward the planet's core. There's no solid surface, no ground to walk on, no land to build a base. If you descended into Jupiter's atmosphere, you'd fall through clouds, then into liquid gas, and finally into an ocean of plasma, all while being crushed by intense pressure and exposed to unimaginable temperatures. Let's not forget about radiation. Jupiter's massive magnetic field creates the most dangerous radiation belts in the solar system. strong enough to fry a spacecraft's electronics in hours. For humans, it's a death sentence. So, could anything survive there? Not likely. The conditions are far too extreme for known forms of life. But there's a twist. Jupiter itself may be lifeless, but its moons are another story. One moon in particular, Europa, hides a subsurface ocean beneath a crust of ice. Scientists suspect it might have more water than all of Earth's oceans combined. Tidal forces from Jupiter's gravity keep the ocean warm enough to stay liquid, and maybe even support life. That's why Europa is one of the most exciting destinations in our solar system. And NASA's upcoming Europa Clipper mission is set to explore its potential in detail. In the battle of Mars versus Jupiter, neither world seems suitable for human life, at least not directly. But both hold clues to the universe's greatest mystery. Are we alone? Mars offers a glimpse into planetary evolution. What Earth might have become if conditions had shifted slightly. It holds the ruins of a possibly habitable past. Jupiter shows us the raw power of planetary formation and how size and composition can create a world that is both magnificent and terrifying. And in their orbits, their moons may become the true frontiers of discovery. So, as we continue our journey beyond Earth, let's not just dream of new homes. Let's understand what makes a world habitable and why so few meet the mark. Because the more we learn about Mars and Jupiter, the more we realize that life is fragile, rare, and precious. And maybe that's the best reason to keep looking. If life is a lottery, then Earth hit the jackpot. But just how rare is a planet like ours? That question drove one of the most ambitious space missions in human history. Welcome back to Infinity Beyond. Today, we explore the legacy of NASA's Kepler Space Telescope, a mission that scanned the cosmos for other Earths and left us with answers, questions, and a sense of cosmic humility. Let's rewind to 2009. That year, NASA launched the Kepler telescope into space with one purpose: to survey a small patch of sky, just 0.25% of the night sky, and look for planets orbiting distant stars. Not just any planets, rocky planets, Earth-like planets, planets in the habitable zone, where liquid water could exist and life might find a foothold. Over the course of its 9-year mission, Kepler didn't just fulfill its mission, it exceeded all expectations. It observed over 500,000 stars and discovered more than 20,600 confirmed exoplanets, with thousands more potential candidates. Among them were dozens that resembled Earth in size, composition, and orbit. That may sound like a lot, but compared to the vastness of space, it's just a grain of sand. Here's the wild part. Many of the planets Kepler found don't look like anything in our own solar system. Most were in a category called super-Earths, planets larger than Earth but smaller than Neptune. We don't have any of those here, which means either our solar system is strange or we just got extremely lucky. And Kepler didn't stop there. It also discovered hot Jupiters, gas giants orbiting perilously close to their stars. Some planets orbit binary stars, like something straight out of Star Wars. Others orbit in clusters of planets packed so closely, their years last only a few days. Kepler revealed a universe teeming with variety, a cosmic zoo of planetary types, orbits, and possibilities. But what about Earth-like planets? Kepler did identify a handful, worlds like Kepler 186f, Kepler 452b, and Kepler 22b, that are roughly Earth-sized and orbit within the habitable zone of their stars. And yet we haven't found a perfect twin. No second Earth, not yet. That's what makes Earth so rare, so precious. It's not just about location, it's about balance. Right star, right distance, right atmosphere, right chemistry. Everything had to align and stay aligned for billions of years. Earth didn't just win the lottery, it won every lottery. every time. But Kepler gave us more than data. It changed the way we see the universe. Before Kepler, we had no idea how common Earth-like planets might be. Now we know that planets outnumber stars. Most stars in the galaxy have at least one planet, and many have entire systems. Some scientists now estimate that there could be 300 million potentially habitable worlds in our galaxy alone. That doesn't mean life exists on all of them, but it means the potential is enormous. We are not the exception. We are part of a cosmic trend, and that idea has changed the focus of astronomy. Today, telescopes like TESS and James Webb are continuing Kepler's legacy. They're zeroing in on the most promising candidates, peering into their atmospheres, and searching for chemical fingerprints of life. Meanwhile, missions like Plato and Ariel are preparing to do the same in the next decade. We are entering a new era, where finding Earth 2.0 may no longer be science fiction. And when we do, it won't just be about proving life exists elsewhere. It will be about understanding what makes Earth so unique, and what makes it just one of many. When you look up at the night sky, even in perfect conditions, you might see 2,500 stars. But in the Milky Way, there are over 100 billion stars, and possibly as many as 400 billion. So why do our skies feel so empty? Because our eyes can't see the invisible, the faint, the distant. But Kepler could. It stared at a quiet corner of the sky and revealed an entire galaxy of planets, hiding in plain sight. So, the next time you feel small, remember, you live on a planet that beat impossible odds, but you also live in a universe that may be overflowing with possibility. Kepler reminded us of both, and in doing so, it brought us closer to the stars than ever before. When Oumuamua was first spotted in 2017, astronomers were stunned. It was moving too fast, had a strange shape, and didn't leave behind a comet-like trail. It didn't behave like any asteroid or comet we'd ever observed. So what was it? Some believed it could be a shard of an alien spaceship. Others thought it might be a previously unknown kind of comet, one made of solid hydrogen or nitrogen. But the more we studied it, the more questions emerged. One of the biggest puzzles? Silence. If it were alien technology, wouldn't it emit signals? Some form of radio wave? Scientists turned powerful telescopes toward it, listening closely, but there was nothing. Absolute silence. No radio frequencies, no signals, no beacons. Just a fast-moving object spinning through space. But silence doesn't mean it wasn't artificial. It just means if someone sent it, they didn't want us to know. To dig deeper, scientists studied how Oumuamua reflected light. Because different materials reflect light differently, this gave them clues about its surface. What they found was intriguing. Oumuamua reflected light like metallic iron or dense rocky material. But even more unusual was its brightness pattern. It would flash brightly, fade, then flash again. Not because of sunlight glinting off its surface, but because it was tumbling, rotating in an unpredictable, non-linear way, like a stick thrown through the air rather than a smooth spin around one axis. This irregular rotation made it hard to classify. Even stranger, the object didn't have any visible propulsion, yet it accelerated slightly as it left the solar system. That's not supposed to happen. Most comets accelerate due to outgassing. The sun heats them up, and gases push them forward like tiny thrusters. But Oumuamua didn't show signs of gas or a till, so how was it speeding up? Some theorists suggested it could be a light sail, a thin object pushed by solar radiation. And that's when the alien theory really took off. Harvard astrophysicist Avi Loeb famously proposed that Oumuamua could be an extraterrestrial probe, a kind of space buoy or piece of discarded alien technology, sent either deliberately or accidentally. According to Loeb, its behavior didn't match anything we know from natural physics, but could be explained by artificial design. Of course, not everyone agrees. Most scientists still lean toward natural explanations, but even they admit we don't have anything that fits perfectly. A hydrogen iceberg? Too unstable. A cosmic dust pancake? Never seen one before. A fractured comet from another star system? Maybe. But then, why the odd movement? Whatever Oumuamua was, it was something new. And it didn't stick around for long. By the time the world began paying close attention, Oumuamua was already leaving the solar system, traveling over 95,000 kilometers per hour. It came, confused us all, and then vanished into the blackness of space, never to be seen again. But its legacy lives on. Since then, astronomers have launched programs to scan the skies for more interstellar visitors. And in 2023, the discovery of Borisov, another object from beyond our system, confirmed that Oumuamua wasn't a one-time event. Interstellar travelers pass through more often than we thought. We just weren't looking. Now we are. Future missions may even send spacecraft to intercept one of these objects in real time. Imagine being able to land on something from another solar system, or retrieve samples from it. The implications for science and for the search for life would be massive. And who knows? Maybe the next one won't be silent. So what was Oumuamua? A shard of alien tech? A cosmic relic? A natural phenomenon we've never seen before? In many ways, it doesn't matter. What matters is that it woke us up to the reality that we're not alone in the galaxy, even if no one else has said hello yet. And that's why we'll keep watching the stars, because someday something else might pass by. And this time, we'll be ready. It sounds like science fiction, but the threat is very real. We've seen the evidence all around us: crater scars on our planet, mass extinction events, and even the infamous asteroid that wiped out the dinosaurs 66 million years ago. So what's our plan if it happens again? Believe it or not, we do have a few strategies. The first and simplest: push it. By using a spacecraft as a kinetic impactor, we can slam it into the asteroid to slightly change its speed or direction. It doesn't need to be a dramatic shift, just enough to make the asteroid miss Earth entirely over time. NASA recently tested this idea with the DART mission, which successfully impacted the moonlet Dimorphos. The result? Its orbit changed. Proof of concept confirmed. Another method? A controlled explosion. This doesn't mean nuking the asteroid like in the movies, although that is one option. Instead, it might involve detonating explosives near the surface to create enough force to alter its trajectory or fragment it into smaller, less dangerous pieces. Then there's the classic sci-fi solution: attach rocket engines to the asteroid. This concept would let us steer the rock like a spacecraft, redirecting its orbit across the solar system. The challenge, of course, is the complexity. You'd need to land, anchor, install engines, and power them, all while riding on a tumbling boulder in space. Sounds far-fetched? Perhaps. But scientists are exploring gravity tractors too, spacecraft that hover near an asteroid and use their own gravitational pull to gradually tug the rock off course. But let's not forget, size matters. If the asteroid is smaller than about 80 feet, 24 meters, it will most likely burn up in Earth's atmosphere due to friction. That's what happened over Chelyabinsk, Russia in 2013. The shockwave shattered windows and injured over 1,000 people, even though the asteroid never hit the ground. Asteroids between 80 feet and half a mile in diameter are more dangerous. They can survive atmospheric entry and cause localized devastation, possibly even a citywide disaster. Anything larger than half a mile? That's the kind of impact that could trigger global consequences: climate change, oceanic tsunamis, mass extinction. We call these planet killers. And yes, we're actively searching the skies for them. But let's shift to something even more bizarre: A place so isolated it might as well be alien, a cave sealed off from the outside world for over 5.5 million years. Located in Romania, Movile Cave is a biological time capsule. With no sunlight, no air exchange, and no connection to the outside world, this cave developed its own ecosystem, completely independent from the surface. What scientists found inside shocked them. Despite the toxic air, rich in hydrogen sulfide, carbon dioxide, and nearly devoid of oxygen, life flourishes here. Dozens of unknown species live in complete darkness, feeding on microbial mats that derive energy not from photosynthesis, but chemosynthesis, extracting energy from chemicals in the water and rocks. This discovery blew open our understanding of what life needs to survive. Why is this important? Because if life can thrive in a sulfur-filled, oxygen-starved cave beneath Romania, then maybe, just maybe, it can survive on other planets too. Think of Jupiter's moon, Europa, or Saturn's Enceladus. Beneath their icy crusts may lie warm, dark oceans, places where life doesn't rely on sunlight, but on geothermal energy, just like in Movile Cave. In other words, this cave doesn't just reveal life's resilience, it might be the key to finding alien life elsewhere. So in one segment, we've explored defending Earth from cosmic threats, and in the next breath, we've seen how life might endure in the most impossible places. That's the beauty of science. The more we study, the more we realize just how interconnected survival, discovery, and curiosity really are. Whether it's saving Earth from a space rock or finding microbes in a poisoned cave, the message is clear. Life is tenacious, and so is our will to protect it. Let's begin in the warm Caribbean waters off the coast of Belize. Here lies a circular chasm in the ocean that seems almost too perfect to be natural. The Great Blue Hole. Spanning over 1,000 feet wide and plunging more than 400 feet deep, this enormous sinkhole is a diver's dream and a scientist's mystery. But how did such a massive hole form? Once upon a time, this wasn't an underwater wonder. It was a limestone cave system, part of the ancient world above sea level. But as sea levels rose at the end of the last ice age, water flooded the cave, causing the roof to collapse and leaving behind a gaping vertical abyss. As divers descend into its crystalline blue layers, something eerie happens. Light fades, silence grows, and strange geological formations begin to appear. Stalactites, giant, sharp mineral spikes, and still cling to the walls deep below. Proof that this was once a dry space. These formations only grow in air, meaning this cave existed long before it became a sinkhole. At about 50 feet down, something extraordinary appears. A shimmering layer in the water, almost like an invisible barrier. This isn't a trick of the light. It's a halocline, where salt water from the ocean meets fresh water trapped below. Cross this line and everything changes. Visibility, buoyancy, and sometimes your sense of direction. Diving further becomes dangerous. Some divers have gone missing, lost in the tight, winding passages that branch off from the main shaft. Others return with stories of unsettling stillness, a kind of sacred quiet that feels both ancient and unknown. Even famed explorer Jacques Cousteau called it one of the top diving sites on Earth. And still, the Great Blue Hole guards its secrets. Now let's shift to another natural wonder, but this one is hidden not beneath the sea, but within the Amazon rainforest. It's known as Shanay Timpishka, but many call it the Boiling River. According to Amazonian legend, this river was feared as a sacred place of spirits. They said the water was so hot it could boil anything alive. And they weren't wrong. Measuring over 4 miles long, this river reaches temperatures of up to 200 degrees, 93 degrees, almost the boiling point of water. Yet it isn't near any known volcano or geothermal vent. So what's heating it? Scientists believe water from faraway mountains seeps deep into the Earth's crust, where it's superheated and then forced back to the surface through fault lines, creating a river that literally cooks its surroundings. Researchers have found dead animals, like frogs and birds, that accidentally fell in. Their bodies cooked from the inside out within minutes. The river is so hot and steamy, it creates its own misty microclimate, a mysterious, foggy world in the middle of the jungle. What makes it even more incredible is that this boiling river was virtually unknown to the outside world until recently. Its existence had been passed down through generations of local shamans and tribal elders, people who had protected the sacred site from intrusion. And once again, this earthly anomaly gives us insight into what life might be like on other worlds. Imagine an alien planet with subsurface rivers heated by internal energy. If life can exist near boiling water here, in sulfur-rich caves and acidic rivers, could it not also thrive in the oceans of Europa, Titan, or Enceladus? These Earth mysteries are more than just local legends. They're analogs for what we might one day find in deep space. From the cold, dark bottom of the Great Blue Hole to the scorching waters of the Amazon, our planet is home to environments that defy logic and continually challenge our understanding of life, time, and geology. They remind us that we haven't even fully explored our own world, let alone the universe. And maybe that's the biggest mystery of all, how much we still don't know. In the infancy of the universe, just a few 100 million years after the Big Bang, everything was supposed to be chaotic, turbulent, and undeveloped. This was the era when stars were only beginning to form. Galaxies were supposed to be small and messy, and light itself had just broken free from the fog of creation. But according to new data from the James Webb Space Telescope, JWST, that assumption may be completely wrong. JWST's ultra-sensitive infrared vision allowed scientists to peer deeper into time than ever before. When astronomers analyzed faint light from objects billions of light-years away, they expected to see tiny, primitive galaxies still forming their first stars. Instead, they found something completely unexpected. Fully formed, massive galaxies, some as large as our Milky Way, already in place just 500 to 700 million years after the Big Bang. How is that possible? Not only were these galaxies huge, but they were filled with mature red stars. Stars that should take billions of years to evolve. Yet here they were, glowing softly in the earliest chapters of cosmic history. If these galaxies are real, and the evidence keeps stacking up, then something about our understanding of cosmic evolution is broken. It's like finding a fully grown tree in the middle of a field that was supposedly planted yesterday. These galaxies shouldn't just be improbable, they should be impossible. But that's not all. The composition of these early galaxies also challenges what we thought we knew. Some of the stars appear metal-rich, meaning they contain elements heavier than hydrogen and helium. Elements that are only formed in older generations of stars through nuclear fusion and supernova explosions. How could such complex materials already exist in galaxies so soon after the Big Bang? One theory is that the early universe formed stars and galaxies much faster than we realized. Perhaps starburst activity, rapid periods of intense star formation, was far more common in the early cosmos than previously believed. Another theory? Dark matter and dark energy played a more aggressive role in shaping the universe than we thought, pulling structures together at a faster pace, accelerating gravitational collapses and mergers. And yes, some even speculate about new physics, forces or particles we don't yet understand, reshaping our models of how the universe came into being. But the mystery goes even deeper. Some scientists question whether these objects are even galaxies at all. Could they be dense clusters of stars or black hole-powered quasars, mimicking the appearance of a galaxy? Could the JWST's instruments be picking up optical illusions, distorted by the lensing of gravity over vast distances? Right now, astronomers are working tirelessly to verify the findings. But if confirmed, this discovery would rewrite textbooks, reprogram simulations, and force us to rethink the timeline of the universe. It would mean the universe matured much faster than we believed. It would also suggest that our place in cosmic history is even more peculiar than we imagined. And this isn't the first time JWST has disrupted the status quo. From spotting carbon-based molecules on exoplanets to revealing galaxies hidden behind clouds of dust, James Webb is proving one thing over and over again. The universe is not what we expected. It's more complex, more dynamic, and, in many ways, more mysterious than any theory dared to predict. So where do we go from here? New studies will reanalyze this early data, apply more precise models, and attempt to peer even further back, perhaps to just 200 million years after the Big Bang, into the era of the first stars. Upcoming observations could determine whether these forbidden galaxies are truly anomalies, or if the early universe was far more crowded, bright, and structured than we ever imagined. Whatever the outcome, one thing is certain. We are witnessing a revolution in astronomy, and it's only just begun. Let's begin with the Cartwheel Galaxy, a true marvel of galactic transformation. Unlike its spiral cousins, the Cartwheel Galaxy doesn't follow the traditional cosmic choreography. Its structure is wild, chaotic, and absolutely mesmerizing. It looks almost artificial, like a wheel suspended in space, complete with a glowing central hub and spokes stretching outward. But how did it form? It all began with a collision. Billions of years ago, a smaller galaxy slammed into a larger one, triggering a shockwave of energy that rippled through gas and dust, like a stone dropped in a pond. The impact sent material flying outward, forming a bright outer ring of young stars and triggering massive star formation as it expanded. Think of it like cosmic fireworks, bursts of gas and dust igniting under pressure, giving birth to new generations of stars. What makes the Cartwheel so fascinating isn't just its unusual shape. It's the fact that it offers a rare snapshot of galactic evolution in action. We're watching a galaxy remake itself, transforming from one structure into another across eons. It's chaotic, it's beautiful, and it's a reminder that even in space, change is constant. Now, let's move on to a more classical, but equally breathtaking example. Spiral Galaxy M74. Located around 32 million light-years away in the constellation Pisces, M74 is the poster child for spiral galaxies. It belongs to an elite group known as Grand Design Galaxies, systems with striking, clearly defined spiral arms that extend gracefully from a central bulge. These arms aren't just decorative, they're stellar nurseries, where clouds of gas and dust collapse to form new stars. Inside M74, astronomers have spotted supernovas, star-forming regions, and intricate dust lanes weaving between glowing clusters of young stars. And thanks to the James Webb Space Telescope, we're now seeing these regions in unprecedented detail. In July, NASA released a breathtaking image of M74, but getting it wasn't easy. JWST had to peer through thick clouds of interstellar dust using its infrared capabilities, revealing glowing webs of gas, glowing stars in various life stages, and even the faint whispers of stars just beginning to form. What Webb showed us is more than a photograph. It's a time-lapse of cosmic creation, frozen in light. What connects the Cartwheel Galaxy and M74 is that both remind us of the complexity of galaxies, how they aren't static islands, but dynamic ecosystems, constantly evolving, colliding, and rebirthing stars. The Cartwheel is a galaxy reborn through destruction. M74 is a galaxy blooming in quiet elegance, and both speak to the violence and beauty of the universe. In Cartwheel, we see the aftermath of galactic chaos. In M74, We see the meticulous architecture of gravity sculpting spiral arms that stretch across tens of thousands of light-years. Both are powered by the same forces: gravity, dark matter, and the unending dance of celestial bodies. And both teach us something fundamental. Galaxies are alive, not in the biological sense, but as systems that change, react, and evolve over billions of years. Every supernova, every cluster of stars, every ripple of dust, it's all part of a vast, interconnected process, one that James Webb is only just beginning to uncover. As we peer deeper into the cosmos, we find that the universe is more than empty space and scattered light. It's a storybook written in stars, and every galaxy, from Cartwheel to M74, is a chapter waiting to be read. So next time you look up at the night sky, remember, you're not just seeing stars. You're seeing galaxies in motion, ancient light traveling millions of years to reach your eyes, each one with a history richer than we can imagine. Let's begin in one of the most active regions on Earth, the South Pacific. This area is home to over 10,000 volcanoes, packed into a tectonically active zone called the Ring of Fire. But volcanoes are just the surface expression of something far more powerful. Beneath Earth's crust lies the mantle, a thick, rocky layer that extends nearly 1,800 miles deep and makes up over 80% of the planet's volume. Though solid, the mantle behaves more like slow-moving caramel, constantly shifting and churning, driven by heat from the core below. And it's in this subterranean world that one of nature's most fascinating processes unfolds: the birth of diamonds. You might think of diamonds as symbols of beauty and luxury, but to geologists, diamonds are time capsules, forged under intense heat and pressure, hundreds of miles below the surface. When volcanic eruptions, particularly from kimberlite pipes, carry these diamonds upward, they arrive as frozen records of the deep Earth. By analyzing the trace minerals and isotopes trapped inside them, scientists gain insight into conditions that existed billions of years ago. And what they're finding is astonishing. Some diamonds contain evidence of water locked away deep inside the mantle. This suggests that Earth's interior isn't just dry, hot rock. It may actually hold more water than all the oceans on the surface combined. Yes, you heard that right. Our planet might be hiding an entire ocean's worth of water deep within its mantle, bound within minerals like ringwoodite, which only form under extreme pressure. This leads to a radical idea. Earth is slowly consuming its own oceans. Here's how. Thanks to plate tectonics, massive sections of Earth's crust, called tectonic plates, are constantly shifting. In regions where plates collide, one often dives beneath the other in a process called subduction. As these plates descend, they drag seawater-soaked sediments down into the mantle. Under crushing pressure, the water gets trapped in minerals, carried deep into the Earth's interior, and possibly stored for millions, even billions, of years. It's like Earth has its own internal recycling system, pulling water from the surface and locking it inside its core machinery. But it doesn't stop there. Some scientists believe that this hidden water may lubricate mantle movement, fuel volcanic eruptions, and even affect the magnetic field. Water isn't just passive cargo. It may be active in shaping our planet's dynamics. And that raises an even bigger question. Could Earth's unique ability to store and recycle water be the key to why life exists here and not on other rocky planets? Mars, for example, once had rivers, lakes, and oceans. But without active plate tectonics, it couldn't cycle that water back into its interior. Once it was lost, it stayed lost. Earth's internal ocean might be the reason our surface ocean still exists today. And it all comes back to diamonds, those glimmering messengers from the deep. They tell us that Earth is alive, not just at the surface, but all the way to its molten heart. That beneath our feet, there's a hidden world of movement, pressure, and chemistry that sustains the conditions for life. In a strange way, Earth is the most alien world we've ever studied. And despite all our satellite data and space probes, we've only scratched the surface, literally. We've drilled no deeper than 7.5 miles into the Earth's crust. That's like peeling the skin off an apple and pretending you understand its core. And yet, thanks to seismic data, mantle minerals, and yes, diamonds, we're beginning to paint a picture of the world beneath our world. It's dark, it's violent, it's majestic, and it may hold the answers to life's endurance on this planet. So as we look to the stars in search of habitable exoplanets and hidden oceans, maybe we should pause and remember, there's still an entire ocean below our feet that we haven't truly explored. And diamonds, forged in that deep fire, are quietly telling us its story. Let's start with the scale. Even if you traveled at the speed of light, it would still take you over 1 billion years to cross the Keplers structure. That's not a typo. 1 billion years, just to move from one side to the other. And yet, Keplers only makes up about 13% of the observable universe. Still, it contains more mass than your mind can possibly imagine. Over 200 quadrillion times the mass of our Sun. So what is Keplers? It's a cosmic superstructure, a massive filamentary network of galaxies, gas, and dark matter that resembles a spider web stretching across space. But this is no ordinary cluster. It's a piece of the cosmic web, the large-scale structure of the universe itself. Its name, Keplers, comes from the Incan system of knotted cords, also known as Keplers, used to record numbers, dates, and even messages in the form of knots and threads. Each twist, knot, and color held meaning. It was an ancient form of communication. Astronomers chose this name not just for its poetry, but because the shape of this galactic megastructure resembles those cords. A long central filament with branching tendrils, just like a woven knot of space. And here's the wild part. Keplers isn't alone. When scientists mapped this region of space, they discovered 5 similar tangled structures nearby, all stretching billions of light-years across. These structures didn't just appear overnight. They formed over billions of years as gravity slowly pulled matter together into filaments, walls, and voids, shaping the architecture of the cosmos. This arrangement, with galaxies forming along the filaments and vast empty regions between them, is what we now call the cosmic web. It's how the universe organizes itself, not in neat rows, but in knotted, twisted strands of light and matter, held together by dark matter scaffolding. To give you an idea of its complexity, think of it like this. If the universe were a forest, galaxies would be the trees. But Keplers is the roots, the mycelium network, the hidden infrastructure connecting everything together. And while we've long known that galaxies cluster into filaments and sheets, Keplers has pushed our understanding to an entirely new level, in both scale and structure. Its sheer size, density, and organization challenge what we thought was possible in the timeline of the universe. How could such a large structure form so quickly after the Big Bang? What forces molded it into these elegant, cord-like shapes? The answer might lie in the dark forces that shape the universe, especially dark matter and dark energy. These invisible forces are believed to make up 95% of the universe, but we can't see them directly. Instead, we observe their fingerprints, the motion of galaxies, the bending of light, and the formation of massive structures like Keplers. Keplers also teaches us something deeply humbling. The universe is interconnected. From tiny subatomic particles to colossal galaxy filaments, everything is part of a larger system. And just like the Incan Keplers told stories through knots, the universe is telling a story through the geometry of its galaxies. A cosmic language, written not in words, but in gravity and light. And we're just beginning to decipher it. Astronomers are now using AI, deep space telescopes, and gravitational lensing to map even more of the cosmic web. Future instruments like the Euclid Space Telescope and the Nancy Grace Roman Telescope will allow us to peer deeper and farther, revealing even more of the hidden skeleton that holds the universe together. So what does this all mean? It means that when you look up at the stars, you're not just seeing dots of light. You're seeing nodes in a vast cosmic network. And you, me, our planet, our sun, we're all woven into this grand design. It also means we're part of a universe that's alive with motion, with galaxies flowing along invisible strands, colliding, merging, and evolving, all within a framework as intricate as it is enormous. Keplers is more than a structure. It's a symbol, a reminder that the universe isn't just chaotic. It's structured, interconnected, and perhaps even intelligent in its design. And as we explore its depths, we're not just uncovering the history of stars, we're unraveling the architecture of existence itself. The cosmic web isn't made of ordinary matter. In fact, most of it is composed of dark matter, the unseen force that makes up about 27% of the universe. And while we can't observe dark matter directly, we can see its effects. And they're nothing short of mind-blowing. One of its most powerful tricks? Gravitational lensing. Picture this. You're observing a distant galaxy billions of light-years away. Suddenly, you notice that its light is bent, stretched, and magnified, as if you're viewing it through a cosmic funhouse mirror. That distortion? It's caused by the invisible gravity of the cosmic web. Massive filaments of dark matter and galaxies that sit between us and the object we're observing. This effect not only confirms the existence of dark matter, it also allows us to map the otherwise invisible structure of the universe. It's like tracing the shape of wind by watching leaves swirl. We may not see the wind, but we see its impact. And those impacts shape everything. The cosmic web acts as the skeleton of the universe, guiding how galaxies form, where they cluster, and how they evolve. Mass flows along its filaments, collecting at intersections called nodes, where galaxy clusters take shape, like cities forming at the crossroads of ancient trade routes. Without this structure, matter would remain scattered. Stars wouldn't clump. Galaxies wouldn't spiral. In other words, without the web, there'd be no structure, no planets, no suns, no us. That's why scientists now say the cosmic web is one of the most important structures in the known universe. And yet, we're only beginning to understand it. Even now, cutting-edge simulations like Illustris and Millennium TNG are helping researchers model the universe's large-scale evolution, recreating how dark matter filaments pull gas and galaxies together across billions of years. What's emerging is a picture of the universe as an intricate, ever-changing tapestry, shaped not just by matter, but by invisible forces acting across incomprehensible distances. But perhaps the most mind-bending part? This structure is still evolving. Even now, galaxies are being pulled along these filaments. Superclusters are growing. The universe's shape is being sculpted in real time, slowly, but surely. And in the far future, as dark energy drives galaxies apart and the universe continues to expand, the cosmic web may become stretched thinner and thinner until distant galaxies vanish from view, leaving only the nearest threads within our observable reach. So what does this mean for us? It means that our solar system, or our galaxy, isn't isolated. We are part of something enormous, woven into a network that spans billions of light years. Every star we see in the night sky is part of this web. Every black hole, every nebula, every atom, all shaped by the same gravitational blueprint. And by studying this vast structure, we're not just understanding space, we're understanding the deep logic of the cosmos itself. The cosmic web teaches us that the universe isn't random. It has form, it has structure, and perhaps, at some level, it even has intention. Whether you believe that's physics, mathematics, or something more, One thing is clear. The more we learn about the cosmos, the more we realize just how much we don't know. And that's what makes this journey so thrilling.